All right, this video is going to be related to making decisions between probabilities for normal, for binomial, and making decisions for a probability versus a confidence interval, and then confidence interval decision making, normals versus t's versus proportions. So what I would recommend that you do is, first of all, start out by just stopping the video right now and writing down the entire problems, or jotting the problems down, or doing a screen capture of the material you see here. So you're going to get problems 1 through 6 right now. And then I'm going to give this about 5 seconds, and after 5 seconds I'm going to pull it down so you can see problems 7 through 9, and then I would recommend doing the exact same thing, pausing the video, writing those down, and then going ahead and doing a screen capture. So what I'm asking you to do is copy or capture problem numbers 1 through 6. Okay, and now I want you to copy or capture problems 7 through 9. Now, stop the video, do the problems. This is how you're going to get the most out of this video, is actually trying to do the problems on your own. And once you've completed those problems, then you should come back and you should see the solutions to each of the problems and listen to the particulars on how the problems were solved, why choices were made, whether it was a probability, whether it was a confidence interval, what the particular details were there. All right, with that said, I'm going to go ahead and I'm going to start solving problems 1 through 9. And again, I will recommend here that you have just stopped the video and do not listen to the solutions until you've actually tried the problems on your own. It won't do you any good to listen to the problems and then try to solve them on your own. Okay, so problem number 1. A manufacturer of thermometers says that when measuring the temperatures of freezing points of water, their thermometers yield temperature readings that are normally distributed with a mean of 0 and a standard deviation of 1. If you've never seen this notation right here, this means normal, this is the mean, this is the standard deviation, and I've put degrees Celsius inside here. It says if 9% of all thermometers are rejected because they have readings that are too high and the rest are accepted, find the temperature reading that separates the rejected and the non-rejected thermometers. So the first thing that we need to know is that we are talking about a normally distributed data set with a mean of 0 and a standard deviation of 1. This means that these are z's, right? Because they are mean of 0 and standard deviation of 1 for the normal distribution. And we know a percentage of thermometers, so what we're looking at here is an inverse normal question. We are looking at 9% of all are rejected, so rejects would be down here, right? And this is telling us that 9%, or 0.09, are rejected, which means that the rest, the 91% of the population, are accepted. And what we're being asked to find is what is this value right here that separates the rejected ones from the accepted ones. This again is an inverse normal question. We're going to solve this by simply saying that this is the inverse normal for 0.09. And once we calculate that value, then we're going to go ahead and give it as degrees Celsius. So I'll take out my TI. I'll do second function for variables. I'll go down to the inverse normal. I'll input 0.09 for the area to the left, and that's going to give me a negative 1 point. And with Beoga, we use 2 decimals, so I'll use a negative 1.34. And then my answer is going to be a negative 1.34 degrees Celsius. And that is the temperature that separates the lower 9% from the upper 91%. All right, now moving on to my next question. I'm going to go ahead and, oops, I have to move this over because I cannot change the page. I'm going to go ahead and I'm going to do problem number 2. So problem number 2, I'm looking at, according to the National Endowment of Arts, or for the Arts, 20% of all women attended a musical play in 2002. A simple random sample of size 300 is taken from the population, and the number that have attended the play is noted. What is the probability that between 78 and 119 women in the sample have attended the musical play? Assume that you don't have a TI calculator to find this probability. How will you approximate the requested probability? Give the probability. Right. See this right here, this percentage? Anytime you see a percentage or an extraordinarily large number of numbers, you are probably looking at a binomially distributed random variable. X, the random variable that we're talking about here, is the number of women who have attended a play, or a musical, attended a musical. And what do we know about attending a musical? Well, you've either attended or you have not attended, right? Attend or not attend is binomially distributed because you have these choices, 1, 2. It's either this or not this. So this is binomial. So X is a binomially distributed random variable. That means that if X is distributed binomially, then we're talking about a proportion here. So these are the things that we need to know. So if we're talking about proportions and we need to say what is the probability here that our random variable is between, actually, right? So it's between 78 and 119, then what we have going on is a binomial distribution, and we know that our P is equal to 0.2. We know that our N is equal to 300, and we are being asked to assume you don't have a TI calculator. Well, how is that relevant? If you don't have a TI calculator, then finding a binomial probability is pretty hard. So what you need to be able to do is to be able to use the normal approximation. And so that is what we're being asked in this approximation. So we're going to use the normal approximation here. So if you don't have a TI, or if you're asked to find the approximate value, right, approximate the probability, then that's what we're going to be doing. So we're going to use our probabilities here to find this. So first of all, I need to do a continuity correction. So my continuity correction is going to be the 78 and then plus 0.5, and then here my 119 minus 0.5. And the reason that I'm doing plus on this side and minus on this side is because it's between. So when I'm between two values, I'm not including the values, right? So between is a strict inequality here and here. And between those, I want to not include the 78. So here's my 78 bar. So I have to start right here, which is half a unit here to this point. And then the 119 bar over here, right, 119, I don't want to include it either, so I have to start here. So I have a half a unit on this side of the bar as well. So that puts me between the two. So the probability that I'm going to be calculating is 78.5 up to 118.5. Now, what I've done with this continuity correction is I've gone from a binomially distributed random variable to a normally distributed random variable with that continuity correction. My x sub n, it's distributed normally with a mean equal to 0.2 times my, oops, not 100, but 300. And then we have a standard deviation of the square root of 0.2 times 0.8, and then times the 300. And that's going to give me my probability here. So that's what we're going to have to do in order to find this probability. Now I don't have enough room. I know the next page is not empty, so I'm going to turn back to the last page, erase it, and start writing again. So I'm going to do this. And now I'm going to actually find my mean, my 0.2 multiplied by 300. So that's going to give me 60. So that was my mean. And my standard deviation that I'm going to use here is going to be 60 times 0.8. And then I'm going to take the square root of that. And so I have the square root of 48 is what it turned out to be. And if you want an approximation, that's approximately, oops, not 6, it's approximately 4, or not 4, 6.9282, like that. So now what I have to do is I have to standardize this probability. So the probability of being between 78.5 and 118.5 is just going to get standardized. So this score is standardized, this score is standardized. So 78.5 minus the mean 60 divided by my standard deviation 6.9282, and over here 118.5 minus 60 divided by 6.9282, and now I'll have my new probability. So my probability here puts me between two z-scores. So 78.5 minus 60 divided by the square root of 48, and I'm actually going to use the square root of 48, so I'm not using that approximation, and I'm only going to use two decimals here, 2.67 on the left side, and then 118.5 minus 60, and then divided by the square root of 48, and that's going to give me 8.45, and then I'm going to use my normal CDF, 4 here, and use my normal CDF to get this. And I'm running out of time, so you'll have to pick me up on the next video to finish this actual probability. But this is what I'm going to do with this put in and this put in to get my answer.